Now, our next sponsor talk is Alan Benjamin for GigaIO. I met Alan for the first time in person on April 25th, 2016. I was impressed by the company, and I'm still impressed by the company. A fabric for high performance computing. And guess what? Now we have AI and these data centers. They're just absolutely perfect for the technology that GigaIO has. So, Alan, please, the floor is yours.
All right. Thank you, Dan. Let me share my presentation. And if I'm lucky, I get my pointer too.
Yep, have at
Okay.
it.
So I'm gonna go through this very quick because it's very short. If anybody has questions, put them into the Slack channel and or contact me directly. But we're going to talk about some of our technology that enables. We are accelerator agnostic within the framework. We enable all of the accelerators, right, to be able to play their part in leading the AI revolution. So I'm going to talk about Supernode, where this is really the workhorse for AI inferencing. But be aware, we also have a really interesting product that's a highly portable suitcase size. It's actually carry-on size, so think more briefcase size, that brings honest to God processing power, including the latest and greatest of the GPUs or video feed, right to the edge. So, as Dan said, when we started, it wasn't about AI, but boy, AI has done great stuff for us. And scale up matters for AI because in inferencing, a lot of the performance is driven by data movement latency, where compute is not the bottleneck, but the data movement latency is. And inferencing and latency equals better user experience and better response time. And when you distribute models over, we'll call it traditional scale out networks, you increase latency and GPUs sit idle. So wasted GPUs, higher TCOs, more difficult setups, that's what we're solving. So the traditional alternative, the main, we would call it the main alternative here is a conventional networking of servers. Let's say you're scaling up to 16 or 32 or 64 GPUs, right? The conventional approach, you use Ethernet, InfiniBand. Today, there's GPU to GPU interconnects, NVLink, NVSwitch. Within the server itself, it could be Infinity Fabric if you're AMD. So you have a variety of networks within the traditional framework, but that's what most people do. Over in a Supernode, we scale up the entire system, right? We use PCI Express as our base fabric. We can also incorporate NVLink boards and Infinity Fabric boards, so we capitalize. The main advantage for us is in latency, and you can see the latency numbers, right? If you go across a conventional Rocky Ethernet, NVLink, fantastic bandwidth, not as good on latency. And across a Supernode, our latency endpoint to endpoint is fantastic. System cost is very similar to what you do with Ethernet. And because of the fact that we're one server, we drive power savings across the board. So the Supernode itself is a true scale-up architecture. It's a full rack, but it's one server. And it doesn't matter. You're connecting dozens of accelerators. Doesn't matter whether they're all the same. Right? I mean, you can have 32 or 64 NVIDIA, H200s or B200s, but you could also have a mixture. And you could have FPGAs, you could have ASICs, you could have GPUs. We're brand agnostic. We're form factor agnostic. So it can be OEM boards, SXM boards, PCIe format. And like I said, latency is fantastic, 300 nanoseconds end to end, which increases your utilization, it increases your performance, and decreases cost. And we've done all the software work associated with this. If you have containers that you're used to dropping right onto a 4 GPU or 8 GPU server, you can drop them directly onto a Supernode, not change a line of code, and you're going to get 4 to 8 times better performance. So I'm going to show you just a couple of slides that talk about performance numbers. What we're comparing here is a conventional scale-out system, 32 GPUs, 4 servers, 8 GPUs each, connected together. The individual groups of 8 were Infinity Fabric. These are all connected together using 400 gig Ethernet, including a rail optimized system for GPUs. And in Fabrics, we connect them together across our interconnect. In this particular case, we were using PCI Gen 4 system at 256 gig. We tried everything possible to keep this the same. So the performance numbers you see are not comparing GPU differences in GPUs. It's the same GPUs, the same number of them, the same processor, memory, storage, blah, blah, blah. And we were trying to isolate to the interconnect and the network topology itself. So we first have a fairly large, although not exceptionally large model, right? A Llama 3 90B model. And you can see time to first token across fabrics compared to the Rocky system is dramatically better. And total tokens per second and requests per second. This is largely indicative of the number of simultaneous users that can be supported on a given setup, and we're about 50% better. Remember, same GPUs, same servers, different interconnect. And a lot of corporate clients in particular want to be able to turn that system and fine tune with it. And we ran that experiment, and we have twice the performance. And if we look at the tokenomics associated with those two cases, right, tokens per watt and tokens per dollar, you can see significant advantages in terms of using a true scale-up network of ours. And that is us in a nutshell, and what we're doing in being able to scale up. Anybody has any questions, like I say, put them in the Slack channel, or I'm happy to just get in touch with me.
Great. Helen, thank you very much. Look forward to getting the slides and going through them at my leisure. Yours and Andy's are so dense that I always need more time to study them. But thank you for sponsoring and for speaking. This concludes the session that I have chaired, and I'm happy to hand it over to Galen for the next session. Galen, it's all yours.